Hi everyone! Today we're going to be taking a look into the world of quadratic equations. So all a quadratic equation is a polynomial where the greatest degree of our variable is going to be 2. So let's say I have a quadratic function where my variable is going to be t. The greatest exponent, or the greatest power that this letter t can have, is the number 2. If the variable has a power that is greater or less than 2, it is automatically no longer going to be a quadratic function. So before we get into the forms in which we are going to see our equations, let's first take a look at the properties of the graph of a quadratic function. If we take a look at this graph over here on our left, we see a U-shaped graph right over here. This is called a parabola. A parabola is the shape that a quadratic function forms when it is graphed on our xy coordinate plane. Parabolas can be located anywhere across the plane. It can be over here. It could be over here. The location of the parabola isn't going to change the fact that it is quadratic. However, what we must keep in mind is that it always maintains its up and down U shape. Parabolas can also appear upside down, like such. So again, it can be anywhere on our coordinate plane, but we either need to have an upright U shape, like such, or an upside down U shape. So these are the different shapes that a parabola can make. Now, let's take a look at our xy function table right over here. And let's say that this function table is simply going to be representing this original graph we have here in pink. So, we see our x values plotted right over here and our y values plotted right over here. So, let's say that if we're starting with x equals -3 and y equal to 18, we can assume that this point will be somewhere around right here. Then we have -2, 8, somewhere around here, -1, 2, somewhere around here, and then we have 0, 0. So as we see, these points are going to connect into a smooth curve on our left side of our graph. Well, here's the interesting thing. If we look over here, these are the exact same y values that we saw on our left side. They're just reversed. So now we have 1, 2, which should be around here, 2, 8, which would be around here, and 3, 18, which would be around here. So if we look, we can actually connect the points across the graph like such. And so we can see that our right side of our parabola over here is just a reflection of the left side of the parabola across the center point. So now, if we look at this center point right here, where both the left side and the right side of our parabola meet, we see this point 0, 0. This is called the vertex of our parabola. The vertex distinguishes between the two separate sides of our graph. So, if we drew a line right down vertically through our vertex, we call this the axis of symmetry. And this is exactly similar to how if we had a triangle like such, we would draw an axis of symmetry right through it to show that it would be symmetrical on both sides. So similarly, we have our axis of symmetry for this graph. There's also another interesting thing that we can see in our input table over here that actually helps us determine if our function is quadratic or not. And these are going to be found in our y values. So if we take a quick look, we're going to look at the differences between the y values that are being outputted. So first, we're going from 18 to 8. Well, to go from 18 to 8, we have to do -10. Then to go from 8 to 2, we have to do minus 6. From 2 to 0, we have to do minus 2. From 0 to 2, we have to do plus 2. From 2 to 8, we have to do plus 6. And from 8 to 18, we have to do plus 10. So clearly, it's not actually going to be a steady constant value that's being added or being subtracted in our y values. That would actually make it a linear function. But the cool thing about quadratic functions is if we now find the differences between these terms that we just found, we might find an interesting pattern. To go from negative 10 to negative 6, we add 4. To go from negative 6 to negative 2, we add 4. To go from negative 2 to positive 2, we add 4. 2 to 6, add 4. And then 6 to 10, again, we're adding 4. So if you look here, these differences are constant. And we call this the second difference. So if all of your second differences are going to be equal when you're looking at your y values, then you know that this is a quadratic function. So these are some of the basic properties that we've looked at today of a quadratic function. And in our following videos, we're going to see how we see these quadratic functions in various different types of equations and forms. For more personalized tutoring and to practice online using online assessments, make sure you check out Prepaze.com. I'll see you all in my next video.